Hi guys, this is Armin Satradin. I am a member of KNTC Robotic team. In this video we are going to talk about some basic concepts about the players on 2D soccer simulation platform. First of all, we're gonna look at some points on the soccer window, which is a monitoring tool for 2D soccer simulation platform. Afterward, we're gonna go through the code and check these features with their exact values. The first point is that before running the agents, all the players' color are black and they are out of pitch. In this case, we say that the players are killed. If during the game our code faces a runtime error, such as referring an invalid index of array, or a division by zero, or also calling a null pointer, the player gets killed. This means that it gets out of the pitch for rest of the game. About players, the first thing that usually gets your attention is they are made of two different colors. The first color is black and the other is the team color, which in this case is red or yellow. The black side is the player's back and the other color is its front. Therefore, as you can see, each player has a body angle just like reality. I'm using Z button for zooming. As you can see, there's a line in the player's body which indicates the body angle. In the following minute, we will talk about it. In the pitch, our angle starts from 0 to minus 180 and 80 to 0. If we move counterclockwise, the angle goes from 0 to minus 118, and if we move clockwise, the angle goes from 0 to 180. By the way, the zero angle is a parallel line with the horizontal pitch line which goes toward opponent goalpost. If you choose a player using the keyboard numbers and then press the V button, you're gonna see a sector which is the player's viewable area. In the non-deterministic and stochastic environments, such as 2D soccer simulation platform, our viewable area can cause in receiving different data. If you set the full state flag to true, this parameter do not cause any changes. Full state is a parameter in server configuration, and by setting this value to true, we would not have any noises and the environment changes from partially observable to fully observable for the agents. By pushing X button, you can zoom out in the soccer window. The player's viewable sector can have up to 3 different angles. The current one, which is 180 and is called wide, being 120, which is normal, and 60, which is narrow. In the wide mode, you will get the data in 3 cycles. In the normal mode, the update time is 2 cycles and the narrow is 1 cycle. So it is a trade-off. By having a larger view which gets more data, you will have them with more delay. By pushing the S button, you will see the player's stamina, which gets decreased during the match by the player's movement. Moving fast or in a direction further than your body angle can cause a faster decrease in the stamina. When the player's stamina gets low, the body back color will turn from black to gray, and if it gets to 0, there would be a red circle around the player. Low stamina causes low movement speed. If you press the E button, we will see that the player have a central part and a circle around it. The central part is the player's body itself, which represents the player's position. The circle part is the player's kickable area, which is the area that the player can kick the ball in it. Also, if you press the T button, you can see the tackleable area of the player either. As you can see, the player number 6 outer body has got white. This means that it's kicking the ball at the moment. During game, players turn to different colors that each indicates a specific situation. For example, red means they have tackled, or green, which means packet lost. Loss usually caused by a large number of computations, and therefore the agent cannot send the packet to the RCSS server in time. So the player gets green and that cycle and do not do anything. Moreover, there is also a catchable area for the goalie, which can be seen by pressing the C button. Now let's go to the code to see how we can figure out each of these parameters' value. In the code, we have different type of classes for the players, such as player agent and abstract player object. We are not going to talk about player agent in this video. Check for it in the upcoming ones. The first thing that we are talking about is abstract player object, which is in the word model class. If you hold the control key and left click on our player, you will get to word model class. And by repeating the same approach for abstract player object, you will get to abstract player object class. As you can see, we have some protected fields in this class, which you can have access to using their getters function. Now we're gonna check each field functionality and how we can get access to. By using our player function in the word model and passing a number to it, we will get access to our player with that number or unit, and it gets returned in the abstract player object format. There are so many different functions available for this player. I really suggest to check these functions later. We are going to talk about some of these functions right now. The first and the most important one is pose function, which returns the player position in the pitch, which is from vector to the class that contains two double parameters for the x-axis and y-axis. The other important function is body, which returns an angle that represents the player's angle in the pitch, and we can have its degree by using the degree function. Another important function is the face function, which returns the angle that the player is looking at. There are also two other functions that are related to the player's position. There are seen pose and heard pose. The player has two different ways for updating its data, through the viewable area and through other players' message. Players can send data to each other. For example, they can say, hey, player 6 is at the following position. Obviously not like this, but somehow similar. The other function is heard pose count, which tells us how many cycles are passed since our last heard data for a specific player. The exact function exists for the scene position. There is also kicks function, which indicates that the player have kicked the ball or not in the exact cycle. Also, there are some other basics functions, such as there is the itself function, which returns a boolean that indicates am I the player or not, somehow asking, hey, is that me? One other important function is player type PTR, which can also be accessed through the word model. The field which is available in the player type, which is not in abstract player object class, is the kickable margin, which is the radius around the player in which the player can kick the ball. Player type also gives us some important computing functions, such as cycles to reach distance. As it's obtained from the name, it gets a distance and then tells us for going that far how many cycles is needed for us. In the agent 2D base, the player can also have access to itself using self function from the word model class. In this case, you will access to all the above functions and even one more function, which returns the player stamina. We can also have access to the opponent's player using their player function in the word model. Also, we can get our teammates sorted by their distance toward us using teammates from self function. It returns a vector of player PTR count. In order of accessing each player in this data structure, you will need to iterate through it using a for loop. You can see the code below. There is also another function available here, which returns the angle that a player is pointing to. It can be an important information in the 2D soccer simulation platform, which is a multi-agent platform. This was a short tutorial on the player concepts. Thanks for watching this video. I hope that it was useful for you. Do not forget to like and subscribe. Wait for the upcoming videos, and also it would be our pleasure to have you as a contributor for preparing more tutorials. So if you like to be involved, do not hesitate to contact us. You can find the ways on the screen. Thank you.